Okay, greetings to everyone. We are having a paper 2 June examination of 2022 that was written in Free State Province, which is this year, 2022. Now, let's just go through the memorandum that I'm going to deliver to you, and explaining thoroughly or deeply to some of the questions, so that you get to understand when the question comes differently, you know how you're going to approach the question. So this is the question paper that I have. Then with it, I am going to do the memorandum of all the questions, possibly yes for all the questions. So by then, if I really deliver what you really want to watch, which means you like the content that I deliver, so please just react positively to my channel, subscribe for more videos, so that you get notifications whenever I post a new video. So let's support each other, ladies and gentlemen, because what your positive reaction, just one click, can change the whole situation. So on that note, enjoy the rest of the video. I will try not to be fast, but to go deep to for you to understand all the aspects of a particular question or a topic that you will be dealing with at that moment. So guys, please enjoy the rest of the video, and also don't forget to react positively on the channel. If you are in love with the channel, which means you have to be a member of the channel. But how do you become a member? It's when you do what is being done by people who are the members of the channel. So thank you guys. Enjoy the rest of the video. All right, paper 2 always starts with the data handling, which is the very first question. Data handling, which is also called statistics, but let's handle the data. Here, on question number 1, we are given the statement. The table below shows the distance in kilometers traveled daily by sale representative for 21 working days in a certain month. So, of course, if this data was taken for 21 days, which means we are expecting these numbers to be 21. So that's the total number of data, which is the very same as the total number of days that the data was recorded. Now, the first question says, calculate the mean distance traveled by the sales representative. 2 marks, which means there is nothing more or much to do here. When you are calculating the mean, forget about some other things. Just look for the keyword mean, 5-number summary, the median, the mode, the lower quartile, and stuff like that. Whatever that they explain after that, if you've got the keyword, just work on the keyword, because some of the things are going to confuse you, but you really have to read the statement in full in case there's another thing that you have to take note of. Now we have question number 1.1 says calculate the mean. The mean, how do you calculate the mean or the average? They can just say the average mean or just the average. That just have to be flexible in using those words, because they mean the same thing. Now, the mean is to add all these things here, all these numbers that are here. You will realize that to calculate the mean, you don't necessarily have to arrange your data, but you can aside so that for other questions, you can just refer to the arranged data. Otherwise, for the mean, you don't have to, but you can, because the rest of the question, probably they usually ask it when it is arranged. But for this one, we really don't have a problem. Even when they were looking for the median, we'll just go to the median immediately, because it is already well arranged from smaller to the highest number, which is it is in ascending order already. Now, for the mean, we just have to add all these numbers. We add all these numbers using our calculator, or we can even show the calculation, but it's really not necessary to show that you have added all of them. You can just add them on your calculator. Then what you just need to write is what you got in your calculator. Now, after finding it, it's probably is gonna be 3,310 divided by, which means this is the total number of this is the total sum for all the numbers that you just punched in your calculator, then divided by how many terms or how many numbers did you add. So dividing by 21. So the answer is going to be just 157,62. Now, this is what we have. So this is the mean. This is the 2 marks that you need to grab. So this is what you have here. Then for the simplification of your answer. So coming to the second one, write down 5 number summary for the data. 5 number summary, ladies and gentlemen, we just need to know that we are dividing our data into 5 quarters. Into 5 quarters. So on that note, we are having the minimum value. Of course, it has to be the lowest one. The maximum value. But let me just go in order. If you have a minimum, then you have a lower quartile, which is the same as just Q1. Then we also have the median, then which is Q2. Then we have upper quartile, which is Q3. Then you also have the maximum value, which is the biggest number that we have. Now, we just need to write down all these things taking from our data. And now, what are we having? For the minimum, we take the lowest one, and it's easy to take the lowest one when the data is well arranged. So we have 1, 3, 1. Well, then after that, we have the lower quartile. The lower quartile, we're gonna come back with it. Then let's just take the maximum. The maximum is gonna be this one. The maximum is 189. So these are the easiest ones to fill them up. Let's come to the next one. Since our terms are 21, which means the 11th term is the median, because that is the odd number that is falling in between of 10 and 10 to get 21. So the 11th term is the median, which is Q2. So counting from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have found our median there, which is 151. Now, coming to the quartiles now, the quartile 1, quartile 2, quartile 1, quartile 3. Quartile 1 is the lower quartile, which means it is the half of the first half of our data. So which means now the first half of our data starts here, which means we are having 10 of these, which means we have 4, which means the 5 and 6 are going to be our median, which means we have 1, 2, 3, 4. We also have 1, 2, 3, 4, which means these ones are our median. These ones are our median. So how do you go about finding the median of 2 terms? We just add them up. Which is 141 plus 144. Then you divide by 2. The idea we are looking for, what is the meager value between these 2 numbers? Okay, what is the meager value between these 2 numbers? Once you add that, you will basically gonna get 142, 5. So that is Q1. Then Q3, how do you get Q3? Which means since this is the median, of course, then on that note, we're gonna count, which is the 5 and 6 are going to be our upper quartile. So 1, 2, 3, 4, 5, 6, which means we can see that we are having these ones, which means the median is going to be between these two values. So of course, the number which is between 72 and 74 has to be 73. So which means the upper quartile is 73. So we do have now 5 number summary. It is 5 number summary because these are 5 things, which is 1, 2, 3, 4, 5. So we have 5 of them. So expect when you are having this data, expect to use it to draw a box and whisker diagram. So on that note, we are having that question. Yes, of course. What are we having now? We have use the scaled line in your answer book. Unfortunately, we don't have it right here, but we know that we have an idea on how do we draw a box and whisker diagram. To draw a box and whisker diagram for this set of data. Now, having it this way, I believe it's gonna be this way. Then what are we having? We have a box. It has to be a box-like thing. That here we have lower quartile, here we have upper quartile, here we'll probably have a minimum, then somewhere here we're going to be having maximum. So once you have these ones, then let's just fill them up. The minimum was just 131. The minimum value was just 131. So here we have 131 as a minimum value, which is 131. So the maximum value was given by 189. So which means here we have 189. This is 189. Then coming to the lower quartile, we found it out to be 42,5. So we have it 42,5. So we have 142,5. Then the upper quartile was 73, I believe. Yeah, this was 73, which was between these two numbers. Now, this is our box and whisker diagram, but there is only one summary that we did not show here, which is very important, and we really have to write it last, because it depends on what you have already in your box and whisker diagram. So the median, you need to have all this information in your box, then therefore later on you will judge the position of it later. So 142,5 is definitely close to it's 140. The median, it's 151. Remember, the median is 151, which is the middle value, which is Q2. Yeah. Now, it's going to be 151 is close to Q1. And we just need to find the difference between your 73 minus 151. 173. It's 173. This is 173. Remember, it's not 73. That one. It's not 73. This is just 173. I'm sorry for that. So 151 is close to 142 because So which means our box and whisker diagram will have the median, which is close to Q1. So we are going to be having it right somewhere here. Now, because the distance from 142 to 151 is shorter or is smaller than the distance that you can travel from that Q2 to 170 to 173. So that is why it has to be close to this Q1. Now, which means we're having 151 over there. Sorry for writing it there, but at least the color can suggest that this is Q2 that we are writing. Then moving to 1.4 says comment on the skewness of the data. So you need to tell us now, how is it skewed? Is it skewed to the left or is it skewed to the right? Or some they use positively skewed or negatively skewed. That's the same thing. So how do you comment that way? Skewness, to know that it is skewed to the right, it's when when it's skewed to the right, it's when this piece is bigger than this one. So that means now it is skewed to the right because the piece or which means the median is close to Q1, which means it has left the big space on the right. So it is skewed to the right, or you can say it is positively skewed. Positively skewed. Yeah, okay? Valento. So this is what we have. Skewed, yes. Now this is what we have. So we just need to judge the position of the median. If it's close to Q1, then it is leaving a big space on the right. If it is close to Q3, it is leaving a big space on the on the left. So now the big space is the skewed that we are going to talk about. So positively skewed because it has a big space on the right. Negatively skewed because it might happen that it is close to Q3 that way, so it is leaving a big space on the left. So this is the idea. We just need to find the difference between the median and these quartiles to see which one has the bigger value than the other. Now, let's come to standard deviation. Standard deviation, ladies and gentlemen, I'm not able to project the calculator, because when I project the calculator, which means I will have to move out of this page to just press the calculator. Otherwise, I will create a specific video on how do you answer statistics using calculator, because at the end of the day, statistics is about pressing the calculator because you are dealing with the data, you are power sensors going and so the idea is to have a calculator and have a skill on how do you answer the statistics using calculator, because the standard deviation, the mean, all those things, they just requires a calculator for you to have it. Now, and I'm sorry for that, because I really had to of course project it over here so that we do everything while everyone sees. Now, what are we having? Calculate the standard deviation of these. I may not have it right here because of that, but anyway, I'm going to create a specific video only for statistics, where we are going to be dealing with how do we answer it using our calculators. So, and forgive me with that, but I can be able to explain what is going to happen on the rest of these things. Now, what are we having? We are having what? We are having 1.6. 1.6 says, the sales representative discovered that his odometer, which is the apparatus that is used to measure this distance, was faulty, which means there was something that was wrong there. So when there's something that is wrong, which means the data or the recordings that it has been taken is probably faulty as well, which means instead of 7, then the odometer just take 21. Can you see that? Instead of 40, it just write 1 million for some strange reasons. Now, so if it is faulty, which means you are expecting something to change in our data. So what is that? The actual reading on each of the 21 working days was P kilometers, more than that was recorded. So that means now that you are having this data, which means it was supposed to give you plus P, there is a value P there that was actually removed by this faulty odometer, which means if P was 4, then this one was going to be 135, and this one was going to be 136, and this one was going to be 144. If that P was 4. So what is the effect of this P now in our statistical representation or analysis? So the idea is to know how the mean is going to be affected. Remember, while you are having 4 here, which means everything changes to add 4. So even the mean that we had previously, that I have rubbed, and I believe the mean was 157.62. So having this mean, which is 157 without the value P, now that the P is being added, just add P here. Because all these values, all these constant values, where there was P that was supposed to be there. So in whatever that you have here, then therefore you have plus P. So that's how the mean was going to be affected if all the terms you add P. Now, the actual deviation, so remember that we had this standard deviation there that we did not calculate, but one thing you need to know, if all these terms, there is P that is being added, that is not going to affect the deviation, because now we moved 4 units, probably we moved P units, it's not affecting the standard deviation, only the mean that is being affected. As you can see that we have added P, so whatever value that we had there with standard deviation, then we're still gonna have standard deviation, which is still the same, because that P is not going to affect the standard deviation. So you just need to know, once something is being changed in the data, what is it that is going to be affected? What is it that's going to remain the same? So that was statistics, ladies and gentlemen, that we have in this paper. And the question 2 is coming shortly. Don't go away. Everybody, welcome to question number 2. Otherwise, feel free to pause the video and try it before you listen to the solution. Here in analytical geometry, we are given a regular diagram, but let's read the statement to see or to know what is it that is in our diagram before we deal with them. In the diagram below, which is not drawn to scale, of course, A, B, C, and D are the vertices of a trapezium having BC parallel to AD. So we have these sides being parallel to each other, and you know that these ones are not parallel to each other because a trapezium have only one pair of opposite sides that are parallel. So T is the midpoint of BD. From B, the straight line drawn parallel to the y-axis, which is from B, we are having this line drawn parallel to the y-axis, like that. That means the value of x in this line is not changing because the line is parallel to the y-axis, which means if here you have 8, here you have 8, here we have 8 as the value of x. So that's what it means for parallel line to the y-axis. So F at cuts DC. This line cuts DC and also cuts the y-axis at M. Now this is just what we have. Moving to a question. The question says, calculate the gradient of AD. calculating the gradient of AD, especially when the line, this line has 2 points, it's easy because you are going to use the formula. So it's always the case that you start with this question in analytical geometry, but if you can't perform the first question, Usham is relevant. What are we having? We're having the gradient of AD, which is given by y1 minus y2 divided by x1 minus x2. So this is what we have. So we can just substitute. We have y1 is 6, y2 is 0. So we may not write that 0. Then x1 is minus 8. Then x2 is minus 2. Then we're going to have plus 2. So the answer is 6 over minus 6, which is negative 1. So the gradient of AD is just negative 1. We have a gradient of AD is equal to negative 1. So in case we forget about that, we just need to remember that we have negative 1 as a gradient of AD. Now, having to 2.2, determine the equation of BC in a form that. So we know that the equation of BC in a form y is equal to mx plus c, we really need to know what is the gradient of that line. We need to know what is the gradient of that line. On that note, BC, we don't have 2 points there, but the information that you have is that this line is parallel to that line. So what does that mean? The gradients are equal. So the gradient of AD is equal to the gradient of what? Of BC. Why is that? Because these lines are parallel to each other. So now we are having the equation of BC, which is what now? Which is y BC is equal to, what is the gradient of BC now? It's going to be negative 1, which means they share the same gradient because these lines are parallel to each other. So we have negative x plus c. So in the place of m, we just put negative 1. So just negative x now. So then we use this point on this line to find the value c because we want to complete the equation. Now, what are we having? In the place of y, we put 10. Then in the place of x, we're going to put 8, which means now we're going to have negative 8, then plus c. Then the value of c is going to be 18, of course. So now what are we having? The equation of that line is just going to be what? The equation of that line is just going to be y is equal to negative x plus 18. So that's the equation of that BC. Now, moving to the next one. Let me wrap this one so that everything becomes clear. Prove that. We are to prove now that, we are to prove that BD is perpendicular to AD. BD is perpendicular to AD. So having that, we need to know that, okay, if BD is perpendicular to AD, which means we are having 90 degrees there. So how do we go about doing that proof? The idea is to find their gradients. The gradient of AD, remember, we have already the gradient of AD, which is equal to negative 1. Now we need the gradient of BD. Because for perpendicular lines, the products of their gradients give us negative 1. So we don't necessarily have to answer we have to prove that using this formula. So the gradient of BD, we need to find the gradient of BD. But let's prove. They don't say this, they are perpendicular. They are just saying prove. So we need to calculate the gradient of BD so that when you multiply by the gradient of AD, if they really give us negative 1, then therefore they are perpendicular to each other. Now, the gradient of BD is what? 10, then minus 0, then divided by, then 8 plus 2. So, which is 10 divided by 10, which is just 1. So, therefore, you can say BD is perpendicular to AD because what? because the gradient of AD times the gradient of DB is equal to -1, because of course -1 times 1 give us -1. So we have proven that they are perpendicular to each other. Now, moving to the next question. The next question says, calculate the size of angle BDM. Angle BDM. Let's look at angle BDM over there. Angle BDM is, let me just highlight, BDM. So which is this angle? We're looking for this angle. So for 2 marks, we just need to, remember, we also have this side. We can just deal with this right angled triangle over there. That OMB is just 10. And what about DM? DM is also 10 because we have 8 up. Remember that the x-coordinate of M is 8. Then from D to M, or from O to M, we moved 8 units. Then from O to this point D, we moved 2 units. But don't mind the direction. So upper, we're having 10 units as well. So we can say, okay, we're not looking for this angle. You can just say tan of that angle is equal to, let's just say, angle BDM is equal to, opposite is 10 units, then divided by adjacent, which is also 10 units, so which is just 1. All right, having this kind of situation, now this tan B, okay, let me just use this one, tan BDM is just going to be 1, then therefore BDM is just going to be 45, because tan inverse of 1 is 45 degrees. So we are having that one now. Then we probably have another way of calculating it, which is what I can say here. We can see that this BDM is the angle of inclination. This is the angle of inclination that we need to take note of. And we know the gradient of BD. The gradient of BD, we just calculated it to be just 1. So now angle of inclination formula is tan, this angle that we spoke about, which is equal to 1. So the angle D, and its BDM, is equal to 45 degrees, because remember we have tan inverse of 1. So we press this in our calculator, then you get your angle, which is this angle. So this is what we have. Otherwise, you can even use sine rule or cosine rule, because you probably have all these sides, but because of the marks that are allocated there, we just need to find the shortest way of calculating all those things. Now, let me just wrap all this. You can always come back for checking if you need another information. Then this is what we have. Yes. Now, moving to the next question, which is on the next page, of course, then we have that one. So we have calculated this one already. We are done with this one. So if it is given that TC is parallel to DM, TC, where is TC, which is, we are having this TC, which we can have a line there, TC parallel to DM, which is parallel to the x-axis. Now, and the point T and C are symmetrical about the line BM. So that means this BM, once they talk about symmetrical, that means this BM, it bisects this two sides. So which means this PM goes right in between of TC. So this is the midpoint of TC. Then the question, calculate the coordinates of C. Calculate the coordinates of C. Remember, if this information was not given, we would be able to calculate the equation, the coordinates of C anyway. But now we are being guided that we are using this information, because now we usually think of having equations being equal at a specific point, because remember, we can even find we have the equation of this line. We can even find the equation of DC, that now we are having point F, which can give us the gradient of DF if we are looking for it, and it's going to allow us to have the equation of DF over there. Now, having these equations, and you can see that they are equal, equation of DC, of BC, and equation of DC, they are equal at point C that way. So we usually equate the equations to find the coordinates. But you cannot use that information now, because we are being guided to use this information, because you may realize that the answers may not be the same if you are using what you know and not following the current guideline of the question. Now, let's use what they gave us. So, which means we are having this one. And the idea is to first have the coordinates of T, because now we need to know. Anyway, upper, we know that the value of X is 8. And we know that when we move in a horizontal direction, we are only moving in the what? In the X direction, which means Y is constant there. We don't care what is the value of Y at that point. We only the 8. So if we can know the coordinates of T and specifically the value of X, the X coordinate of T, is going to take us to know what is the distance from T to this point. That now we're going to travel the very same distance from that point to C. So we're going to find now the coordinates of C. Now, what are we having? Let's determine the midpoint of BD, which is the coordinates of T. So the midpoint of DB, which are the coordinates of T, is equal to, we know that we have x1 is 10 plus y plus x2, which is this is x1 is this one, which is 8, then plus x2, which is minus 2, then divided by 2, then therefore y1 is 10, divided by y2 is just 0, then therefore this is what we have, then therefore we can just write 8 minus 2, which is 6, divided by 2 is 3, then therefore 10 divided by 2 is just 5. So we have the coordinates of T, which is what? Which is T is 3, is 2, is to 5, just like that. So on that note, we know that to move from here to here, we moved how many units? So the idea is to just say 8 minus 3. 8 minus 3, we moved 8 units. This is 8 units, then minus 3, then 8 minus 3, which is just going to be 5 units. So from T to this point, I can call it point M. Sorry, M is already there. I can call it point J. Yes, point J. So from T to J, you moved 5 units. So you have to move 5 units to C as well. So then now we have 8 here. Now we have 8 here. Yes, now we have 8 here. Let's move 5 units to the right. So we have to add 5. So after adding 5 now, which means you are going to be having 13. So we're going to be having 13 here. So at this point, we're going to be having 13. So the coordinates of C is going to be 13 is to remember that this line is parallel to the x-axis, which means the y value does not change. So we do have the y value right from t, then we can just write the y value there. So the coordinates of C, when we use this information, is 13:5. Now we are done for that. Now the idea was to note, okay, what do we do? Calculate the coordinates of t, then therefore once this bm bisect this tc, which means it is going to be in the midpoint, then we need to know how do we travel, what distance do we travel to from this point to the another. Now let's calculate now the area of triangle BDF. The area of triangle BDF. The area of triangle BDF. So this is the triangle that we need to calculate the area of. Now, what we can do here, there is a lot. There is absolutely a lot. Because what you need to know is that from B to F, you can find that that length. From B to F, you can find that length, because now you're gonna say 10 minus 3 1/3. So we have 10 minus 3. 10 minus, it's 10 minus 3, then 1/3. So which is gonna be 20 over, which is gonna be 20/3, which is 20/3. That's the distance from F to B. That's 20/3. And you can also calculate the distance from B to F, because you have both coordinates, and the distance from this one. So by doing that, you can just think of E cosine rule, because if you have all the sides in a triangle, you can always find the angle that you want. But nonetheless, if you don't take that one, because we are going to have this one, which means we are going to have cos that angle, which is, let's just call it angle D, is going to be equal to, use the cosine rule to figure out the angle there. So what are we having? We have this side, DB squared, then plus this side, which is DF squared, then minus this side, which is what? BF squared, then all divided by, then 2 times BD times DF. So this is what you have. I believe you are familiar with the question, with the formula like this, which is generated from that question of that formula for E cosine rule. Because if you have all the sides, you can always calculate the angle of that triangles. So we can find this one then by using this one. So that after having this one, we use the area rule, because now we'll be having this side and that side. So the area rule is gonna be, which is the area of triangle BDF, is going to be angle, is going to be half, then a base. Base can be any side that are going to put this angle that we're talking about in between. So which means gonna be BD times DF, because we have these sides, we're going to be using these sides, then times sine of included angle, and that included angle is gonna be BDF, that we have calculated right up there. So that's gonna be the area. This is one way of calculating it. Then let's look at another way of finding this area. If we have one, what can we do there? We are having, this is the triangle that we are focusing on. if this is a triangle, you can see that this line over there is perpendicular to this, what you call this base. So we can see that since this triangle is an obtuse angled triangle, because this equation, this angle is right above 90 degrees. So the height of it, the perpendicular height of this base has to be outside the triangle. So now this this side is going to be acting as what? The perpendicular height of this triangle. So this must be the base of this triangle. So on that note, knowing this side, which is 20 over 3, so the length of it, how did you go about finding it? We said 10, which is the biggest number, minus the smallest number of y. So we said 10 minus 3 or 3. So this is the same as just 10 minus, this is 10 over 3. So this is just, we have to have, then we ended up having what? 20 over 3. Now, what are we having? What are we having now? We have, yes, of course, having that one, we can say half, then base. The base is going to be this 20 over 3, then times perpendicular height. And the perpendicular height is going to be the distance of MD, which is MD. MD, we found it to be 10 because from M we have 8, then from D we have -2, which means from 8 to -2. How many units have you traveled to the left? You have traveled 10 units, so times 10. So whatever that you get is going to be the area of this triangle. So I did not calculate it, otherwise this is how it's done. So thank you for this one. Let me check if we are done with this example. We are done. So see you right in the next question shortly. Thank you. Bye. Everyone, welcome to question number 3, which is analytical geometry part 2, whereby we are dealing with the circle. Now, knowing the geometry around the circle. We are having a beautiful circle, of course, that we are going to be dealing with throughout this question. In the diagram, N is the center of the circle. N is the center of the circle. Then M, P are the points on the circumference. This is what we see. Then MNP is the diameter of the circle, which is, this is our diameter of the circle. Then the tangents drawn to circle from R outside the circle meets the circle at S and M respectively. So which means these tangents, they are from R, they go to S and M in that way, in that fashion. Now, this is the information that we have two tangents. Remember, two tangents that from the same circle, therefore these sides are equal to each other. Just remember that, which is a theorem that is used in Euclidean geometry. It does apply here as well, because tangent is a tangent. Tangent. Now, the first question says, determine the coordinates of N, which is the midpoint of, or the center of the circle. In short, the center of the circle, but it's just the midpoint of point P. So we just need to use the midpoint theorem to find the coordinates of M. Then the coordinates of N, we're gonna have the midpoint, which is coordinates of N, which is x is to y, is equal to, what are we having? We have x1 plus yx2 divided by 2. Then we have y1, which is 4, plus negative y2, then divided by 2. Then in short, the coordinates of N is going to be -1, is 2, just 1. So these are the coordinates of the center. These are the coordinates of N, which is the center of the circle. We have used midpoint theorem because N, which is the center, is also the midpoint of a point of the diameter MP. Now, let's come to the next question. Determine the equation of the circle in the form that. Wow. So in the form that. So we are having this form, which is just a form to fill it in. Then y, we have that, then is equal to r squared. So one thing you need to remember that is that this A and B are the coordinates of the center. This A and B are the coordinates of N, respectively. This is the value of A, this is the value of B. So on that note, you just need to know that here, these X and Y are any coordinates on the circumference of the circle. It could be S, could be P, could be M. Any coordinates that are on the circumference of the circle. On the circumference. Circumference right there at the circumference. Now, what do? We need to do the substitution because we really need to know what is the value R there. Now, what are we having? We have X and Y. So we can use these coordinates in the place of X and Y, and these coordinates in the place of A and B. So let's continue. Let's just do it. And we are having 1. Then and the value of A is -1. Then therefore when negative and negative give us positive, then we have that. Then plus Y is 4. We have 4. Then B, we have this one is positive. Then it's going to have this negative. Then we're going to have -1. Then therefore all squared is equal to R squared. Then I believe that our R squared is going to be just 13. Our R squared is just going to be 13. Just going to be 13. So this is what we have. Of course, if we are to look for R, our R is going to be root 13 because R squared is 13. You just put the square root to find R from R squared. So this is what we have. Otherwise, for the equation, we really don't need R. We just need R squared. But you can find R squared when you have R, and you can find R when you have R squared. You just need to be flexible when it comes to that. So let's write the equation now. What are we having? The equation must be in terms of X and Y. So that is why you have to know what is A, what is B, and what is R squared. So that in your equation, you don't have A or B or R squared. You have numerical values of those the values of those variables. Now we have X in the place of X. Now in the place of that one, you put X, then X plus 1, then squared, then therefore we have Y, then -1, then all squared is equal to 13. So this is the equation that we have now. Moving to the next one. Determine the equation of the tangent RM. Where is RM? This is RM. In a form this. So we have 5 marks here. So something that you need to remember here, that, okay, if this is a tangent and this is a radius or diameter, doesn't matter, we just need to know what is the relationship of these lines. The relationship of these lines is that they are perpendicular to each other. The tangent is always perpendicular to the radius or the diameter at the point of intersection of the same circle, right? So which means the tangent is always perpendicular to the radius. So that means the gradients, the product of the gradients always give us -1. So which means if we can find the gradient of one line, we can always find the gradient of the other lines if these lines are perpendicular to each other. So we really need to know now to find the gradient of mn or the gradient of pm, because these points are collinear to each other, which means the gradient is the same. So you can use any point in this line. And these are collinear points, which are the points that are found on a straight line. So what is the relationship? Then therefore the collinear points have the same gradient. So if you calculate the gradient between any of the 2 points, if the points are collinear, you are always going to get the same gradient. Now, what are we having? Let's just calculate the gradient of PM, because I completely forgot the coordinates of n, but I can always move back. But anyway, let's just use MP to find the gradient of the diameter. So the gradient of MP is equal to we have 4, which is this one, then minus 2, which is going to be plus 2, then divided by 1, then minus 3, then that is just 3. Then therefore we have 6 over 4, which is just going to be 2, which is going to be 3 over 2. So this is the equation of the diameter, which is the same as the equation of the radius. Now, that's going to help us to find the equation of Rm, because now if these lines are perpendicular to each other, then therefore the gradient of Rm is going to be the negative reciprocal of what we have over there. So it's going to be 2 over 3, which is negative. So that means we have the gradient of mr that we can now do our equation, which means mr, which is equal to negative 2 over 3, then x, then plus c. So now we can use any point there to find the equation of this line. So now let's just use let's just use these coordinates, which is these ones, because we have to use the coordinates of m to find the value c. So in the place of y, we put negative 2. Then in the place of x, we're going to put negative 3 plus c. So if you do your calculations, you will find that your c becomes just negative 4. So your c becomes just negative 4, because these cancel that. Then you are having negative 2 there, negative 2 times negative 1, which is positive 2. Then this 2 move to that side, then becomes negative again. So c is negative 4. So the equation of mr is going to be negative 2 over 3 x, then minus 4. So that is what we have. We have managed to calculate the gradient of mr by knowing the theorem around the diameter and the tangent. What is their common relationship in order for us to find the gradient of the missing gradient of a specific line. Now that is what we have. Coming to 3.4. 3.4, it says, if it is given that the line joining S to M, that way, is perpendicular to the x-axis, which means this is the line perpendicular to the x-axis, determine the coordinates of S. So we are to determine the coordinates of S. What are the coordinates of S? Okay. But then what we know is that if this line is perpendicular, we spoke about this in the previous example, that if the lines are perpendicular, if the lines are parallel to y-axis, because if it's perpendicular to the x-axis, then it is automatically parallel to the y-axis. So which is the same scenario that we have already alluded. Now, if this line is perpendicular to the x-axis, which means the x-coordinate does not change. So we already have negative 3 as the x-coordinate of S. This is S, remember? Then therefore, the y-coordinate. Now, we can always find the y-coordinate by taking this x, because remember we have the equation of our circle. We have the equation of our circle, and this is the equation of our circle. Let's just use this this one. Let's just use this one. Now we are having this x, s is -3 is to something that we are to find. Now what are we having? We have, in the place of x, you put -3. Just put -3 in the place of x. You put -3, then -3 plus 1, then all squared, then plus, then y, minus 1, all squared, then this is equal to 13. So we are looking for the value of x, remember. Now what are we having? This one, we just have what you call, we have -3 plus 1, it's -2, then this is just going to be 4, then plus y squared, then minus 2y, then plus y is equal to 13. Then therefore, what are we having? We have y squared, then minus 2y. Then when we take this 13 to this side, we have -13 plus 1, it's -12. -12 plus 4, it's -8. So minus 8 is equal to 0. Then you can determine the values of y over here. I think there's another way of doing it because it's too long for 2 marks, I believe. Then what are we having here? We have 8 and we have 2 there. What are the factors of 8 that when you add them, they give you 2? I believe it's 4 and 2, and this one is negative, this one is positive. Then therefore our y becomes just -2, then y becomes just 4. Then if we are dealing with a -2, which means we are going to be having what? 4 here. We're going to be having 4 here because y cannot be negative. Pi we coordinates is the x. So which means this -2 is this one. Because of course, -2, it's when x negative is -3, you get this value for y and this value for y. So this is just what we have. The coordinates of s is that. Another way of doing it, because it seems to be a long method that I've just explained, but nonetheless, we're gonna see what to do next. What are we having? We have 4 there, but let's just call it off. I'll come back if I got another method. Now, what I have next is determine the coordinates of R, which is the common external point from which both tangents to the circle are drawn. So, which means we are looking for the coordinates of R now, which is now we are having this one. So, for 4 marks, we need to know what to do. Here at point M, we do have the equation of MR. Remember, we do have the equation of MR, yes, and we just need now the equation of RS. The equation of RS, we are going to find it by first finding the gradient of Sn. Let's find the gradient of Sn. The coordinates of n is -1 is to 1. Then this one is -3 is to 4. Then the gradient of Sn is equal to 4 minus 1 divided by -3 plus 1, which is going to be 3 over -2. Then this is equal to -3 over 2. So that is the equation of what? Of that. And this is the gradient of this line, which is -3 over 2. So that means the gradient of RS is going to be the gradient of RS is what? Is going to be 2 over 3, which is positive because it has to have the different sign. So we have that one. So that means the equation of RS, is now going to be 2 over 3, then x, then plus c. Then what do we use? We are going to use the coordinates of s in the place of x and y. Then y is 4, then is equal to, we have 2 over 3, then we have negative 3 here, then plus c. Then our c becomes, we have this one cancel this one, so we have negative 2 here. Then when we take this negative 2 to that side, we get 6 as the value of c. So on that note, we have y is equal to 2 over 3x plus 6. So this is the equation of RS. So the equation of RS is y is equal to 2 over 3x plus 6. So, and this one, we did calculate it, the equation of Rm. Let me just the reference. Rm is negative 2 over 3. Is negative 2 over 3 x, then plus, it was plus negative 4, which is minus 4. So we have these equations that are equal there, that we can just that we can just equate them to find that the equation, the coordinates of R. Then after having all the equations of these two lines, you can always equate them so that you get where these two lines are intersecting each other. When you equate these equations, you'll get the value of x where these two equations are equal to each other. So let's just do it here. Let me just rub this one. We just have all this information, by the way. What we can do, we are going to add them up, equate them up, which means the equation of RS is equal to the equation of RM at R. So that is why we're going to equate this equation and this equation to find the coordinates of R. Anyway, now what are we having? The equation of RS is 2 over 3x, then plus 6, then is equal to the equation of this one is what? It's 2. What are we having? Is also 2 over 3 is minus 2 over 3, then x minus 4, minus 4. So this is what we have. So on that note, you can realize that we are having 2x over 3 plus 2x over 3, which is equal to minus 10. Minus 10. If we take the 6 to the other side, then it's going to be minus 6 minus 4, which is minus 10. So when the denominators are the same, we can just add all this. Then we have 2, we have 4x over 3. Then this is equal to then 10, then minus 10 of minus 10. Then therefore we have 4x over 4x is equal to minus 30. So that is going to, the answer is going to be minus, when you divide by 4 both sides, it's going to be minus 15 over 2. So you have minus 15 over 2 over there. So that is the value of x of, if we look at R, then therefore what we can do, we're going to say y is equal to, we can use any of these equations. Then let's just use that one over 3. Then in the place of x, you put negative 1, 5 over 2. Then plus 6 over there. Then therefore the answer is going to be, what is this one, cancel that one, then this one, and that one, then we are left with negative 5 here. then 6 minus 5 is just going to be 1. So on that note, the coordinates of r is just x is negative 1 5 over 2, then therefore y is equal to 1. So we are done solving that one, but I think there is also another way of approaching this question, because let me just wrap this one, because what I notice is that these are the properties of a kite. This side is equal to that one. This side is equal to that one. All right. So that means if this side is perpendicular to the x-axis, then that one has to be parallel to the x-axis, because these sides are already perpendicular to each other. So that means if this is parallel to the x-axis, then therefore the coordinates of r and coordinates of n, they share the same y coordinate. So which means the coordinate of r, the coordinates of r now after that analysis is what? It's we don't know x, but you know that y is equal to 1. So what's the reason for that? We can say diagonals of a kite. So they are perpendicular to each other, and Rn is parallel to the x-axis. And yeah, you can just mention that there's a diagonal, the diagonals of a kite, they do that. Or you can say Rn is parallel to the x-axis. Yes. So that is what we have. Or you can say Rn is a horizontal line if Sm is a vertical line. So that is what we have. So on that note, after having that information, we can say, because we have this information, we can just use one of the equations there. Let's say we didn't have this equation because we found it because we had to find it. It's only this one that was calculated previously. So on that note, you can just use that one. So CT is no y is 1 is equal to negative 2 over 3, then x minus 4. Then of course I believe we're gonna get negative 2x over that. Then it's minus 5. It's gonna be, yes, it's gonna be plus 5. Then because we are taking this one to this side, then it's gonna be plus 5. Then therefore we have 5 times 3 is 15, and divided by negative 2 is going to be 15 over 2. So the coordinates of r is now equal to negative 15 over 2, then is 2 is to 1. So this is what we have so far. So I think that another way we can just try to equate the equation, the distance between these two lines. We can just create the distance. Remember, we have this side, this angle, this point, and we have that one. So we can just create the distance is equal to this distance. So we can just say r s squared, which is the distance of r else when you square it, so that the square root will move away, then rm squared. So once you can use this one, then therefore you continue, because anyway the x value for both terms is just negative 3. So you are going to get rid of x, then therefore you solve for y. So I really don't want to go there because we have already done a lot in this one question. So let's then go to what you call question number 3.6. 3.6 says, calculate the area of RSNM. The area of RSNM, which means RSNM, which is the area of that. So, what do you think? The area of this is the kite, remember? And we also know that the area of a kite, what is the area of a kite? Area of a kite kite is equal to, if you know the distance of these diagonals or the length of these diagonals, the area of the kite is the same as half the product of their diagonals, which means half times SM times Rn. So if you know the length of SM and the length of Rn, you can always find the area of that kite, and then that's it. Or you can use find the area of this right angled triangle plus the area of this right angled triangle, and to all of them they require a distance formula to be used. You cannot run away from that. But yeah, so this is how it is, and yeah, you can approach this question that way, but please, I would like not to do it so that we finish up with other stuff. So I think this was the last question for question number 3. Yes, of course. Then thank you guys for watching, and see you right on question number 4. Everybody, welcome to question number 4. We are doing trigonometry in this question. And of course, we are simplifying a given expression using reduction formulae. Now, we are having all these complicated situations that we need to squeeze it or to reduce it to a simplest manageable trig ratio, which means we are going to have a single trigonometric ratio after we have done all this reduction procedure or process in this 4.1. So you can see that 6 marks, you can take it all. It's highly possible, 100% possible to take this 6 marks as it is. You just need to be positive enough and know the nature of your quadrant. So what are we having here? We have this gradient, this equation, this what you call. Now, what are we having? We're gonna apply some skills to deal with this question, and please just bear with me. I'm not trying to change how you know this or how you've been doing it, but this is another way, on another vision or another way of approaching this question, which can be helpful to most of you learners. Now, what are we having? We have this kind of situation. We are to reduce this complicated one to a single acute angle inside. So what are we having here? We have to ask ourselves, what is 180 where 180 belongs to in our Cartesian plane? If we have 0 here, we have 90 here, we have 180 here, we have 270 here, we have 360 here. We know that here we have 90 minus x. Let's just have x for now. And here we have 90 plus x, which is 90 plus, we move in an anti-clockwise direction. And we also have 180 minus, which means when we move back, which is 180 minus the acute angle. Then here we have 180 plus x. Then we also have 270, which is 270 minus. Then also here we have 270 plus x. Then here we also have 360 minus x. So, and also here we have 360 plus x. So 360 plus x goes straight to the first quadrant. So this is the first quadrant, this is the second quadrant, this is the third quadrant, this is the fourth quadrant. And we know that in the first quadrant, all of them are positive. In the second quadrant, on the sign that is positive. Third quadrant, on the tan that is positive. Then fourth quadrant, this is C that is positive. So you have your cast diagram that is in that form. And now let's come to this one. What are we having? We have 180 plus. 180 plus, we have already discussed about this. 180 plus is found on the third quadrant, where tan is where it belongs. So it has to be positive. Whatever that we do there, it has to be positive tan x. So what are we having? We have tan x. We have changed that one. We have changed that one, and we got the mark by changing that one. Now let's come to this one. Cos 360 minus. 360 minus is in which quadrant? 360 minus, we are having it right on the fourth quadrant. And I believe this is where cos is positive. This is where cos belongs. So that is why we are going to just have cos x, just like that. Then we're done with the numerator, moving to the denominator part. Now, what are we having? We have x minus 180. X minus 180 is the same as x minus 180 plus 360. Remember, this equation is really, this angle is negative because you have subtracted the big angle from the small angle. So that means it is going to confuse you at some point, especially if you haven't dealt with negative angles. You just need to have this skill of changing the negative angle to a positive angle. How do you go about doing that? Whatever that you have that it seems to be confusing because of subtraction, a big number from the small number, just always add 360. Just say 360 plus all what is given. Then you will see that having this one, we have 360 minus 180, which is just gonna give you 180, then therefore plus x. Then you will see that this thing on its own, it belongs right on the third quadrant. It may be confusing because, yeah, of course. So on that note, you can see that it belongs to the third quadrant. So 80 minus x, 80 minus x is on the second, but x minus 80, you move in a clockwise, in an anti-clockwise direction. So this is just the vice versa of what we just did, but for you not to be confused, you just need to know one procedure, and if you master that procedure, don't even take any other person's procedure. It's too late, especially if you're in grade 12. Just don't dare take any of those if you already master a certain one, and it's okay. Now since this one is found on the third quadrant, then sorry, we had this, yeah, we have this, let me not we have this, we have tan. Then sine is on the third quadrant is negative, so we're gonna have negative sine x, just like that. We now no longer have 80 because you know what 80 help us to do. Now let's come to this one. 90 plus x. 90 plus is found on the second quadrant. We know that, and even our cast tells us the very same thing. But there's something amazing about 90 and 270. What is that? It's that when you have 90 or 270 or any multiples of 90 from 0, you can just remember that the trig ratio has to change. If you have cos, then you are going to write sine. If you have sine already, then you have to write cos as to change the trig ratio. Now, I think in a previous video, I have already explained how does these things change and why. So now we just know that, okay, this is the second quadrant, and cos, if this is 90 plus, it is going to change to be sine. So you just need to ask yourself, what is the sign of cos in the second quadrant? It's negative. So it's going to be now negative sine, negative this trig ratio that is changing to. So it's negative sine x. So let's come to this one. So we have 720. 720 is not in our charism plane, unfortunately, but we can always reduce this 720 but by saying 720 minus 360. 720 minus 360 is just 360. So that means if we just subtract, we have 720 and plus x, then subtracting 360, you are not changing the point, you are just changing the nature of the angle. You want to work with this manageable angle. So after having this one, you realize that you have 360 plus x. So 360 plus x, we spoke about it. It is found on the first quadrant. So wow, I like it. Then therefore this one now is going to be found on the first quadrant by just minusing 360, because if the angle is too big, subtract 360. If the angle is too small, such as that it is negative, add 360 so that you deal with the manageable angle. So on that note, we are having 360 plus, which is found on the first quadrant. And on the first quadrant, we know that cos is positive, or everything is positive on the first quadrant. Usekaya kulu kwa first quadrant. Now, what are we having? We have cos x, just cos x. Then let's come to this one. What are we having here? Cos negative x. Negative x, these are the negative angles. Remember, when you have negative angles, you can always add 360 so that you know where does this angle belongs. So when you add 360, just have 360, then minus that angle is found on the fourth quadrant. So which means our cos is positive on the fourth quadrant. So basically, this is what we have. So let's just move a bit on the numerator. We have tan x, then cos x. Tan can be changed to be cos, because remember, we are trying to reduce these things. So when something is changeable, let's just change it. So tan is sine over cos times this cos now, then times cos, then divided by, then remember that we have negative sine x times negative sine x, which can just give us positive sine squared x, then plus cos x times cos x is just positive cos squared x. So what do we need to remember are the identities. So for example, here, this one cancel that one, then we will be left with just sine x in the numerator. Then in the denominator, what do you know about this? We know that sine or cos, doesn't matter what or in which one you started with. The idea is that when you add them together, there is no effect. Then it's equal to 1. So just divided by 1, so the answer is just equal to sine x. So that is it. This is just a single trigonometric ratio that you should have simplified your expression to it. So done with that one. Yeah, let's just go to the next one. The next one, we are having this kind of situation. Now, 4.2 without the use of a calculator, which means the calculator here is not required. So we are to determine this expression. We need to simplify this expression as far as we can. So for 5 marks, which means we need to work. But in trigonometry, I like it because some of the ticks, they are just there because you have remembered something. And you don't have to work hard with trigonometry. By changing this to this, there's a mark. By changing this to this, there's a mark. That's lovely. I enjoy it. It's really an amazing thing to do. Now, what are we having? We have this thing and that one. Look at the numerator. The numerator itself, it gives us the identity that we know about. So that that we know that cos 35, cos squared 35 minus sine squared 35 is equal to cos 235. So this is the double angle. But now you can see that there's something fishy there, something twisted. But nonetheless, by changing it, there is a mark that will be granted. Because now you can see, you cannot say this is equal to this. They are totally different. So this is the skill that you need to obtain when you're doing in trigonometry. There are things that look similar, but they are not the same. Now, having this one, we can try to change it to look this way. Remember, factorizing is always something that can take you from nowhere to somewhere. Now, for this one, let's say we are having sine squared 35 minus cos squared 35, all divided by 4 sine 10, then times cos 10. So what we can do here, how about trying to change this thing to be the same as that one? What that means, we can just take out the common factor in the numerator, which is -1. When you take the common factor, which is -1, you are trying to change the signs of anything that is in a function. So when you take out negative, you will of course have this thing that you are familiar with. Then minus sine squared 35. Then all divided by. Then in this one, you know that we can break this 4 to 2 times 2. Then sine 10, then cos 10. We know that 4 can be broken down to 2 times 2, right? So this is just the skill that you need to obtain. Then moving forward, we just know that this one on its own is the identity, which is the double angle of cos. That we can just say we have negative cos 2 times 35. Well, we're going to simplify it later, by the way. Then all divided by. What we know, there's something we remember about this one, that when we have 2 sine x cos x, it is the same as just sine 2x, which is the double angle of what? Of cos. Of what? Of sine. That means this one can be just 2 times this one on its own, the one that I circled, is just going to be equal to sine 2 times 10. Wow, isn't that amazing? Now what are we having? We have the numerator, which is negative cos 2, then 35 is 70. 35 times 2 is 70. So we have negative cos 70 divided by, this is what we have. Then we have 2 times sine 20, because 10 times 2 is 20, or 2 times 10 is 20. So what are we having? We have 70 and 20. Something that we understand, something that we understand, that if you have sine and we have cos here, and the angles that we have, they add up to 90 degrees. We just need to know or to remember the co-functions or the co-ratios. That now this one seems to be equal to this one. They are equal to each other because cos 70 is equal to sine 20, or cos 30 is equal to sine 60, then cos 45 is equal to cos 45. So that is why they are equal to each other, because when you add those angles, they are always supplementing to 90 degrees. Now, what are we having? We have just negative 1 over 2. So the mistake that usually made by learners is that when there is 2 which is left there, they just have negative 2, which is the genuine mistake, but it is going to cost you a lot, because we cannot understand that we know that negative half can never be equal to negative 2. Not even close to each other. Now, this is what we have for this question, and this is the final answer, which is negative 1 over 2. Then let's move to the next question, if we have one. Wow, 4.3. 4.3, we are having this kind of situation that we have sine 35 is equal to k. Sine 35 is equal to k. So once you see something like that, just go straight to your diagram. Remember the Isosceles, that if you have 35 here, and you have k here, and you have k here, no, let me not say we have k here, we probably have that k, but at the end of the day, we need to explain why does it supposed to be there. Then on that note, if you have 35, this is 90 here, and you have to say 90 minus 35, you are going to get 55. So this is a right angled triangle, the diagram that you are going to be using, because you are not allowed to use anything else. But even if you are allowed, what would you use if not the diagram? I don't know. But yeah, just try to be inventive and do your nice stuff, which is, of course, this is what we always running away from, because you usually do things that are not allowed. Now, what are we having? We're having this one. Then we understand that a sine is opposite over hypotenuse. So which means we are having the opposite over hypotenuse, which means k is opposite of 35, of course, over hypotenuse. Hypotenuse is just 1. The fact that k is divided by nothing, it doesn't mean that it's divided by 0, which means the hypotenuse has to be that something that is not written, which is always 1, right? Now, we are having that one. So Pythagoras theorem can help us, because at the end of the day, before we go through to answer all the steps, we need to have everything in this diagram, that all the angles are there, all the sides are being calculated. So what are we having? We have 1. We are looking for this one now, which means we are having x squared, which is this one, is equal to 1 squared, which is the hypotenuse, then minus k squared. Then k is going to be 1 minus k squared. So this is just what we have for now. In the place of x, we have just 1 minus k squared. So you just need to know how to use your Pythagoras theorem and not to confuse the things. Now, what are we having? We have that one. So let's move to what are we having? To this one. What is cos 45 equal to? Cos 55 equal to? Cos 55, we have 55 here, and we know that cos is adjacent over hypotenuse, and the adjacent side of 55 is k, and the hypotenuse is 1. So the cos 55 is just equal to k. Then it explains what we have done in the previous example, that now since 35 and 55 give us 90, then therefore when these trig ratios are different, they are going to give us the same value. Now you can see that this cos 55 is giving us the same value of sine 35. So these are the core ratios. They are still continuing explaining the same thing. Isn't it lovely? Now we are having sine 45. Sine 45. Sorry for that. We have sine 45. 145. Sine 145. We just need to know what make 145. And in our angles that we have, what can give us 45? So what can give us 45 is what? Is 145 is made of sine, then 180, then minus, of course, 35. So that means now, if you have 145, we're going to just say, okay, 180 minus is in which quadrant? Oh, second quadrant. Oh, sign is positive there. So what are we having? We have that kind of situation, which is going to be sine just 35. So which means, of course, this is still just k. We still have k, because 135 sine 35 is just k over 1, which means this one is still equal to k. Isn't that beautiful? Now, coming to this other one, then we have cos 70. Oh, sine 70. Sine 70 now, we don't have 70 here, we don't have 70 here. But what makes 70? Is it not 35 times something? Yes. So, which means we are having now sine 2 times 35. To get 70 is just 2 times 35. So you can see that now we are having the double angle that we never anticipated, but this is the double angle that we have, that we need to familiarize ourselves on how to expand the double angle of sine, the double angle of cos, of course. Now, what do we have? We are having sine 70, which is sine 2 times 35. that is equal to 2 times sine 35, then cos 35. So we are just expanding the double angle of sine. So what do we do here? We have 2. What is sine 35? Sine 35 is found to be k. It was given there, which is k times. What is cos 35? Cos 35 is given by this over that, which is sine 35 is adjacent over hypotenuse. So with the adjacent side is equal to root 1 over k squared divided by 1. No, 1 is not necessarily to be put there. So this is what we have. So that is it. That is it. Nothing else that you can do. You just need to leave it this way unless you can simplify it further. But nonetheless, we are having this last question, which is cos AET. All right. Cos AET is equal to what? Cos AET is equal to what? So remember, we have sine 70, sine 70, sine 70, sine 70 is equal to that. Sine 70 is that, but otherwise we need to find a way of using these ones if they can help us. So what are we having? We are having what can we do? Because at the end of the day, we probably need a special angle, and one of these angles that are here that we can think about, which is now cos AET is equal to, how about 45 is a special angle. 45 is a special angle. What is 45 plus 35? Isn't it AET? It is AET. So that plus 35. Plus 35, it gives us 80, because 4 plus 3 is 7, plus 5 plus 5 is 10. So yeah, we have 80. So we have these ones. At least this one we can deal with it because it's a what? It's a special angle, and this one we can deal with it because it is in our diagram. So on that note, having this one, we just need to remember expansion of this compound angle. Now we no longer have double angles. This is a compound angle. So let's try to expand it. Now what are we having? Cos 45 plus 35 is the same as expanding the cos. We have cos 45, then cos 35, which means cos, they go in one position. Then therefore minus, we always change the sign for cos. Then we have sine 45, then sine 35. So this is what we have now. Then moving forward, we're going to substitute by what we know. Then cos 45 is a special angle that we can just write it as root 2 over 2. So it's 1 over root 2, which is also root 2 over 2. So times cos 35. Cos 35, I think we did calculate cos 35. If not, but let's just write it up. Cos 35 is adjacent over hypotenuse, which is just root 1 minus k squared. So which is root 1 minus k squared. So then minus sine 45. Sine 45 is also root 2 over 2. Then sine 45 is not k. So it is equal to k. So on that note, we can just take away the square root, the common factor, which is root 2 over 2. Then when we take it out, we're going to be having root 2 over 2 into, what are we having? After this, we are having 1 square root 1 minus k squared, then minus k. So this is just what we have for now. Then after that, I think we can just end there, unless there is more to calculate. Otherwise, this is just what we have. We just need to get a skill of factorizing in case they really need the factor, the simplified answer for this one. But for now, I think it's simple but not simplest. But let's just leave it there, because the idea was to unpack what is required when you are given cos 80. You just need to find or to use the special angle and the angle that is in your diagram, and if not, just add all those things. Just use the special angles and the angles that are given. They will probably give you these things, so just use it and get it done. So thank you guys for this question. Let's check. We are left with this one last question, which is prove the identity. Proving the identities must be just the game of phone. To you, let's just admit that this is not that difficult. You just need to take these marks and move on. Now, what do we do for this one? We are having, okay, still moving. We are having 2x, cos 2x. We have cos 2x, then plus cos squared x, then plus 3 sine squared x, all divided by 2 minus 2 sine squared x. We are proving it to be equal to 1 over cos squared x. So this is what we have. So what do we do now? The idea is to change what is changeable. So for example, that one, it's a target. We need to change that one because it's a compound, it's a double angle. How do we change it? I think we need to use sine and cos, because we have sine and cos over here. Let's just change it to be in a form of sine and cos, because we can't run away from a trig ratio there, because they are already there. Now, what are we having? Let's just change it to sine and cos. So cos 2x is equal to cos squared x minus sine squared x, then plus this one now, which is cos squared x, then plus this one, which is 3 sine squared x. Okay, then divided by, which means we are dealing with what? The left hand side. We are trying to make it to be equal to the right hand side. Now, in the denominator, you can just remove this common factor. We don't know where it's leading us to, but for now, let's just remove it, so that anyway, it's going to help us. Now, what are we having? Because we have this kind of thing, now we can see that cos and cos, we can add them to give us 2 cos x squared x. Then this one and that one, we have 3 sine squared x, then minus 1 sine squared x. We'll be having just 2 sine squared x, because 1 is going out. And then divided by 2 into 1 minus sine squared x. So we're having this one. So what we can do, or what we see, is that there is a common factor over here, that is 2. So now we can take it out. So we have 2 into, then we have cos squared x, then plus sine squared x, then all divided by 2, then 1 minus sine squared x. So having it done, you can see, remember that this on its own is an identity which is equal to 1, and this one cancel that one. So in the numerator we already have 1. Then this one, we know the identity 1 minus sine squared x is the same as cos squared x. So in the denominator we can just put cos squared x. So we can see that indeed the right hand side is equal to the left hand side. So which means now the left hand side is equal to the right hand side. So this is what we have on this question. Then moving to the next question. The next question says, If sine x minus cos x is equal to that, without the use of a calculator, you calculate or determine O sine 2x. Without the use of a calculator, determine sine 2x. All right, for this one, 4.5, we have sine x minus cos x is equal to 3 over 4. Let's calculate the value of sine 2x without the use of a calculator. So here, sine x minus cos x, there is absolutely no identity around these two things, which means there is no relationship when they are like this. But we know that, because we cannot change cos to the in terms of sine, or sine in terms of cos, because it's going to be complicated even more, because we're going to be having square root and stuff like that. But what we can do now, because we are having this sine x minus cos x is equal to 3 over 4, what we can do, how about trying to change the nature of the, we are not going to change the nature of the question, but we are actually going to change how it looks, that we know that it is allowed in mathematics. That how about squaring both sides and see what is happening? Because if we do something on the left and we do the very same thing on the right, the equation remains the same. So we still have the very same thing because we applied the square on both sides of the equation. So we haven't changed the nature of the equation. It's still the same, because if you can put the square root both sides, it's going to go back to its normal state. Now, after having this one, let's just deal with the left-hand side, knowing that the right-hand side is simple to be 9 over 16. So this one is going to be, we have sine x minus cos x, the brackets. Then we have the same thing over there, that we can just expand it and apply our FOIL. Then this right hand side is just 9 over 16. Now the left hand side is equal to, we have sine times sine, which is sine squared x. We have sine squared x, then therefore we have sine and that, and cos and that, which is just going to be negative 2 sine x cos x. Then therefore we take these last ones, which is going to be negative times negative is positive, then it's going to be positive cos squared x, which is equal to just 9 over 16. I don't know where it's going, but probably it's going to where we are sent. Now, what are we having? We can see that this one and that one, they give us a specific identity, which is equal to 1. Remember the identity that we've been using. It's very usual here. So we have 1. So this one and that one, in the place of them, we can just write 1. So we have 1. Allow me to just write 1 here. Then minus 2 sine x cos x is equal to just 9 over 16. So having this one, you can see that after having this one, take this one to the right hand side, and you take this one to the right hand side, you will see that you are having negative 2 sine x cos x, which is equal to, it's going to be, we have 9 over 16 minus 1, which is of course going to give you just 7 over 16. It's going to be 7 over 16. So that is just going to be it. 7 negative, it's going to be negative 7 over 16. So this is what we have. So we can divide by 2, not dividing by 2 per se, just divide by negative 2, just divide by negative 1. So when you divide by negative 1, you will basically get this positive 7 over over 16. But you remember this one is the double angle of sine, which is sine 2x is equal to 7 over 16. So now indeed we were to find what is sine 2x if this is equal to that. So we managed to get sine 2x by just doing that one. So on that note, it just needed the trig part was to know that squaring both sides doesn't change the nature of the question. It just helps you to deal with it and have some more identities than before. So this is just what we have for this question. Do we have another question? No. Yes, for this one. Welcome to question number 5. Let me just finish this trigonometry thing. Question number 5 says, given the equation this, then show that the equation can be written in the form of tan x is equal to negative 4 minus root 3. That's 4 marks. Now, what are we having? We have sine x minus 60. We have sine x minus 60. Oh, this is plus 60. Then plus 2 cos x is equal to 0. So having this one, you really need to remember the compound angles here, because you cannot squeeze this one, because you can't say this is just sine x, just simple like that, because this is a trig ratio. This is the special angle that you can deal with it. Let's just go straight and apply the compound angle. Let's just expand this one. So expanding this one is going to give us sine x, then cos 60. Then you know that cosine, the sign does not change. So we keep the positive as it is. Then we have cos x, then sine 60. So then plus 2 cos x is equal to just 0. So this is what we have. Now let's try to find out what is cos 60. Cos 60 is equal to just 1 over 2, because cos 60 is equal to sine 30, which is equal to 1 over 2, then 1 over 2 sine x, then plus what is sine 60. Sine 60 is equal to root 3 over 2 from our diagram. Then therefore cos x, then plus, then 2 cos x over there. So this is what we have. So on that note, you can see that what is happening here is that we are having these two things that are like terms. So when they are like terms, we can just add them up for the reason of what? Yeah, let's just have this one. That is, if we can take these things to the right-hand side, we can probably have negative 2 cos x, then minus, this one has to change the sign as well. So minus root 3 over 2, then cos x. So this is what we have. So on that note, we have 1 over 2, then sine x. So what are we having? We have, we can just apply the numerator here, the lowest common denominator, just multiply by 2, just multiply by 2, by 2, by 2, so that we get rid of this 2 there, so that everything becomes simple. So on that note, what are we having? We are having, if we do that, we're going to be having these 2 cancel that one. We'll be left with just sine x, which is equal to then 2 times negative 2, which is going to be just negative 4 cos x. Then therefore these 2 cancel that one. You'll be left with just negative root 3 cos that. So on that note, we can just say, okay, since this is a common factor, cos is a common factor that side, Then we have sine x is equal to taking cos as a common factor to have a negative 4 minus root 3. Then what we can do, how about let's check our what we want to solve. And sorry for that, let me just expand it. We want to prove that this is equal to that. So we have tan there. So tan can come out when we divide by cos both sides. When you divide by cos both sides, then this cos cancel that one. Then the sine of a cos is just equal to tan x, which is equal to, yes, we are going to be left with 4 minus root 3. I think this is what we're proving, that this must be equal to that. So we are done with that question. Then moving to, that was question number 1. Question number 2 says, determine the general solution if this is what is given. Now, what we have, we can wrap this whole thing. Otherwise, you can always come back when there's something that you really want to remind yourself about. Then, also this one. In fact, the whole thing must be just get going. Now, coming to this one, we know that tan is equal to that. We did solve that. Tan is equal to this. Then determine the general solution of the equation this, and we know that this equation can be written as that way. So we can just deal with this simplest one so that we don't confuse ourselves or we don't do a big thing. So we are having this one. Now we're determining the general solution. The general solution, so we are going to find what is x. X is equal to tan inverse of this constant on this other side. So we just need to press our calculator so that we find the reference angle. Then the reference angle is going to be what? The reference angle is going to be, when you press the calculator, you press this whole thing, shift tan of that, you are going to get rounding off to 2 decimal places. Then you're going to get x being equal to 80, then comma 10 degrees. So this is our reference angle. So on that note, because we want the values of x in this interval, then we know that since this is a reference angle, then we can always plus 180 over here. Then therefore k is an element of integer, so that you find the rest of other angles. So when we put k being equal to a certain value there, we're going to get x being equal to, when you put -1 here, then your answer is going to be 99.9. When you put -1 here, because -180 minus 80.10 is going to be 99.9. Yes. Now another one, when you put negative, when you put what here? When you put negative there, you are going to get negative, or x is going to be negative 80. X is going to be negative 80. Going to be negative 80.10. So we are going to have this one. So you can see that the values that we have, they fall under this interval. Otherwise, you can find the rest, but at the end of the day, they want us to get the values of x that falls under this interval. And you can see how easy it was, because we did not go straight to this one, because we have already calculated it to be equal to that one. So we just need to use the simplest one than the biggest one. So this is what we have. So on that note, for the drawing, I'm always lazy to draw to do a drawing, but nonetheless I'll come specifically for it. By the way, just enjoy the rest of this trigonometry. See you right on question number 5.3. Shortly, I'm coming back. Thank you, guys. Welcome to question number 7. Everyone, we are having this first question, which says, complete the following. We need to understand how to state a certain theorem in these kind of questions. The angle between the tangent and the chord, it is equal to the angle in this alternate segment. It is equal to the angle in the alternate segment. You don't have to shorten this thing up. Just for at least this completion of these statements, write in full sentences. Now, equal chords subtends equal angles at the circumference of the circle. At the circumference of the circle. So just these 2 marks, just get the 2 marks and go to the next question. So the next question says, here we are having a lovely diagram. We're having a lovely diagram that says, in the diagram, ST and VT are the tangent to a circle at S, and such that at S and V respectively. So we are having this tangent and this tangent. So remember that if you have the tangent from the same points, then they are going to be equal in length. Now, what are we having next? R is the point on the circle, and W is the point on the chord SR, such that WT is parallel to VR. So now we are having this line, which is said to be parallel to that line, which means once you have parallel lines, you'll be having alternate angles that are equal. You will be having corresponding angles that are equal. You can also be having co-interior angles that are supplementary. So what are we having? SV and VW are drawn. SV and VW are drawn. WT intersects SV at K, and you can see that they let OS2 to be equal to X, and this is X, and WVT is equal to 77 degrees. So we are having WVT, which is this whole angle is just 77 degrees. So probably that information is going to be used somewhere. Now, the first question says, write down with reasons 3 other angles, each equal to X. So on that note, after having given all this information, we need now to identify other 3 angles that are equal to X. So on that note, since we have given that S2 is equal to X, what are the angles that are equal to S2? One thing you need to remember is that this is the tangent, and this is a chord of a circle, and the angle between the tangent and a chord is equal to the angle at the alternate segment. Remember the very first statement that they gave you, you can see that we're using now what? We're using this theorem to this equation, this question. So now you can see that this angle R is equal to X as well. So on that note, you can say R is equal to, angle R is equal to X. Reason, this is tan chord theorem. Now, moving to the next one, what are we having? We have what you call, we have parallel lines. We have parallel lines. So having parallel lines, this line is parallel to this one. So that means these angles are corresponding to each other and they will be correspondingly equal. So we have R3, angle R3 is also equal to X, reason corresponding angles. Angles are equal because of parallel lines. You can specify which lines are parallel. It's the best way is to specify them, but then I just don't have space there. Now, we are short of one last angle, which is equal to X as well. Why did we use the tangents? We have not all of them. Let's consider that this side is equal to this side because these are the tangents from the same point outside the circle. So their distance has to be, or the length of them, it has to be equal. So that means having this triangle STV, it gives us now an isosceles triangle, remember? Now you can see that also if this side is equal to this side, then therefore even the base angles are going to be equal to each other. So that means ROV3 is also equal to X. The reason these are the angles opposite equal sides. So we are having this one now, which is also equal to X. So we have found three angles with reasons that are equal to X. That is 6 marks. You get the statement, the reason, the statement, the reason, the statement, the reason. Just 6 marks. Moving to the next question. The next question, remember that whatever information that was given previously, it can be used to this one unless it is stated otherwise. Now we are having 7.2.2. RSTV is a cyclic quadrilateral. Then RSTV is a cyclic quadrilateral. And we know the properties of a cyclic quadrilateral. That, okay, if it's a cyclic quadrilateral, these bow ties are going to be equal to each other. They are going to be equal to each other. Yeah. So, by the way, what is the question? Determine with reasons the size of WST, which is this angle, this whole angle. And you will remember the information that was given previously that WVT is equal to 77, which means WVT, which is this angle, is 77 degrees. So what do you remember about a cyclic quadrilateral? Cyclic quadrilateral, the opposite sides of it, there is the sum, or the sum of opposite angles is equal to 180 degrees. So the opposite side, the opposite angles of a cyclic quadrilateral, they are supplementary, so they add up to 180 degrees. So that means if that is the case, then WST is going to be equal to 180 minus 77 degrees. The reason, these are the opposite angles of cyclic quadrilateral. Now, on that note, 180 minus 77, it's gonna be just 103. That's just 103. So this angle is what? Is 103 degrees. So moving to the next question. The next question we are dealing with the proof. Prove that with reasons, this triangle is an isosceles. Isosceles triangle is when two sides are equal, or you can just use angles. If two angles are equal, then therefore the triangle is gonna be the isosceles triangle. Now, where is this triangle? WRV. WRV, this triangle. They want us to prove that it is a what? It is an isosceles triangle. So that means we either prove that this side is equal to this side. If not, this side is equal to this side. If not, this side is equal to this side. If not, this angle is equal to that angle. If not, just around that triangle, that two things must be equal. Two angles must be equal. If not, two sides must be equal, which means we are going to use the information that is provided to you, because if you don't have any length or any information about length, you can't use them. You just need to use the angles. Now, how do we then go about proving that this triangle is an isosceles triangle? This triangle. What we know is that this angle is equal to x. We did prove that these are the tangent chord. We can say that since that is equal to x, and we know that, what is it that we know? We know that since these sides are parallel to each other, since this side is parallel to this one, we know that alternate angles are equal to each other. Well, now, on that note, what we can do, we know that this angle is equal to that angle. Remember that here you were given that WS TV is a cyclic quadrilateral. So that means this angle it's also equal to that one. So which means S2 is equal to W2. They are both equal to X as well. So raising angles from same segment. So these are the angles from same segment. So they are equal to each other. So on that note, we can now say, okay, since this one is x, this one is also equal to x. So that means now V1 is also equal to x. Raising, these are the alternate angles. These are the alternate angles. Let me change the what? V1 is equal to x. Raising, these are the alternate angles because of parallel lines. Because of parallel lines. So the alternate angles are equal. So then you can say, therefore, W R V is an isosceles. This is C isosceles triangle, because two angles are equal. Now, moving to the next question. Prove that triangle WRV is similar to triangle TSV. The triangles that we're comparing, it's WRV, which is this triangle, and another triangle is TSV, which is TSV. We're comparing these triangles now. How are they similar to each other? Are they similar in a way? But what I like about this order of letters being written here, we know that W is going to be equal to T, but how? We're going to figure out the reason. Then R is going to be equal to S, but how? We're going to figure out. Then V is going to be equal to itself, which is going to be, we're going to find the reason why. Now, we need to just figure out, okay, how W, which is W in this triangle, is going to be W1. How can it be equal to T? if we don't have that information, probably these are the third angles of triangles that have to be equal to each other. Let's move to the next one. So we have done some proof, but the idea is to start your question by introducing your similar triangle, the triangles that you are comparing. So we are having in triangle WRV and triangle TSV. What do we notice? We notice that angle R. Do you remember when we were proving that this angle is also equal to that one? Yes. So which means angle R in this triangle, this side, is equal to angle V3 in the other triangle. Reason we did prove. We did prove that. Or you can say it's what? It's the, yeah, it's the tan chord theorem. Now, moving to the next one, we did prove that this angle is also equal to that one. Okay? Now, which means V1 is equal to S2 in the other triangle. Yes, S, X, X. What's the reason for that? We did prove that. We did do what? We did proved. Then we can now conclude to say, okay, W1 is also equal to angle STV. The reason for that, these are third angles of triangles. They have to be equal to each other. If two pairs of corresponding angles are equal, then therefore the third ones are going to be equal to each other. Wow, that's lovely. Now, on that note, you can conclude to say, okay, therefore, triangle WRV is similar to triangle TSV. Reason, we have proved all the corresponding angles to be equal to each other. Now, let's move to the next question. The next question says, prove that RV divided by SR is equal to KV divided by TS. Okay, first of all, we need to first use our corollaries because now we have this. We say, okay, we have WR divided by TS. It is equal to RV divided by SV. It is also equal to WV over TV. Okay. Now what we have, there are things that we don't have here, but this one, we can see that we have something that has to do with RV in our proof that we just can take it and use it. But for now, we can just say similar triangle for the reason for this corollary. So what are we having? We have VR over SV. SV is equal to, let's take what? VR over SV. VR over SV. It is equal to W. Okay, we can say W. Can say W. Okay, let's say we have WR divided by TS. Okay, so having this one, we also know that having this corollary, we can just cross multiply. So to find RV times TS, it is equal to SV times WR. So we have this kind of situation now. And moving to forward, we are having something here. Let me just rub this one. We are having these triangles that are similar to each other. That we are having this triangle and this triangle. I can say they are similar because there is a line parallel to the third side of a triangle. So we can always apply proportionality theorem when there is something like that. So on that note, I can say, because in my proof I have USR, I can say I also have WR somewhere, that WR or SR over WR, okay, SR over WR is equal to SV over KV, okay, over KV. So we have that kind of situation. So we can say WR over SR, WR over SR over SR, it is also equal to KV, which is KV over SV, which is KV over SV over SV. So we're having this one. So because now we have taken it from from the line parallel to the other side, so we can say prop theorem. Prop theorem, because they are the line that are parallel to each other. So this is what we have. So we can basically do the cross multiplication even here, that we have WR times SV is equal to SR times KV. Okay, so this is what we have. Now you can see or notice that we had SV over WR here, which was equal to this side, and we also have SV times WR here, which is equal to that side. So that means if these things are equal to the same thing, if these things are equal to the same thing, which is this one, which means they are also equal. So that means RV times TS is equal to this one, which is SR times KV. Okay, so because they are equal, so you can write the reason, because they are equal to WR times SV. So since they are equal to the same thing, they can just be equal to each other as well. So on that note, we can just work around this one. So as okay, when you are having this one, we can just say we know that we have RV over RSR, which means we can divide by TS times SR or RS, both sides. Yeah, let me just wrap this one. TS times RS. Yes, so this one cancel that one, so that we are having, remember we are having SR, yeah, which means we are having RV divided by SR, which is RS anyway, then is equal to, then this one cancel that one, they are the same, then we are left with what? KV divided by TS. So this is what we have, so far. So these two things are equal to each other. So the idea is to work around, use proportional theorem, use similarity, and try to figure out how can these two things work out in a writer. So on that note, I can just take this away so that we go to another way of doing. Everyone, welcome to question number 8. Question number 8, ladies and gentlemen, this is, you can just study this one and understand it, master it, because the idea is to construct the perpendicular heights of the triangles that you are dealing with, and also construct this one and find the ratio of the area of this triangle and that triangle, the ratio of the area of this triangle and this triangle, then therefore done. So otherwise, you can just start this one. Let me just not waste time. If you really want to see the proof of this one, you can just, I'll put the link below for the previous video that I did the proof of this kind. So I don't want to repeat the same thing. Just go to my previous video, which was on the memorandum of Eastern Cape DBE question paper, June 2022. So you can just get this proof as it is. So moving to the next question. The next question is question 8.2. 8.2, we are given something fish there, and you can see that there are parallel lines that give us some information. In the diagram, ABC is a triangle having BC parallel to ED, and EA is parallel to GF, and it also given that the ratio of AB is to BE is 1:3. Now we have AC is equal to 3 units, and EF is equal to 3 units. Then F is equal to 3 units as well. Where's DF? DF is 3 units. Then EF is equal to 6 units. Yes. So the first question here says, calculate given reasons the length of CD. The length of CD, where is CD? This is CD. And ladies and gentlemen, let's remember what is given in the statement. We're given that AB is to BE, which is AB is to BE is the same as 1:3. So that means AB is to BE, or EB, is equal to this over that. Can you see that? So that means it is equal to AC over CD. So we can put our ratio on our AB and BE. So AB is 1, BE is 3, then therefore AC is given as 3, then CD is given as the unknown, or DC. So then CD can be calculated and find that we have this is equal to just 9. So CD is equal to 9 on its own. When you cross multiply CD times 1, then 3 times 3 is just 9. So it's just 9 units. So we are done calculating what? Calculating CD. Let's come to the value of x. The value of x, this is x. So the value of x, ladies and gentlemen, we need to remember some other proportionality that we are given this side parallel to this other side. So we need to use that proportionality as well. So on that note, we know that if we're looking for x, which is we are looking for GC, that we can have this proportionality. And remember, ladies and gentlemen, here we said prop theorem. This is prop theorem, or because they are parallel lines. Let us not forget to write the reason in each and every statement. Now, what are we having? but I almost forgot. Then, but we did, both of us. Now, what are we having? We have df divided by fe, because we are using df over fe. Df over fe is equal to dg over ga. So you can see how it goes. So dg, which is dg over g, this is g over ga. So you can see that it's still prop theorem. Now, what is df? Df is 3, then divided by fe is 6, then is equal to, what is dg? Dg is equal to, dg is dg, abo? So dg is equal to, dg is equal to what? Dg is equal to, because you know that this CD is equal to 9. We calculated CD to be equal to 9. So DG is equal to 9 minus this portion, which is 9 minus x. So DG is equal to 9 minus x. Make it clear. So this portion is 9. And this one is going to be 9 minus this portion. So this is what we have divided by GA. Our GA is also equal to, GA is 3 plus x. So which is this whole portion there is 3 plus x. So we're going to be having 3 plus x over there. So you can see that you are having just a fractional equation that we can solve. What are we having? When you cross multiply, you will realize that we are having 3 times 3 is 9, then 3 times x is just 3x, then this is equal to, then 6 times 9 is 54, then 6 times negative x is negative 6x. So this is what we have. Then taking x to this side, then we will be having just 9x, then is equal to, then 54 minus 9 is just going to be equal to 45. Then therefore, when you divide by 9 both sides, you will of course get 5. So that is the value of x that we have calculated there using proportionality theorem. So these are the questions that they don't even challenge you. You just need to remember, okay, when the lines are parallel, what are the corollaries that I'm going to be having on it? What I'm going to be having. For that, so this is just what we need to find out. So moving to the next question. The next question is, we are calculating, so x, we found it to be 5, and this one, if CD is equal to 9, so this DG is going to be what? It's going to be 4, because 4 plus 5 is equal to 9. So you can always insert all the information that you have received so that you don't make mistake by hand. Now, what are we having? We have to calculate the value, okay, the length of BC. The length of BC. Length of BC is the same as, we need to just have a corollary, because we have parallel lines anyway. So that is the short angle, the short side divided by the long side is equal to the short side divided by the long side. So this is what we need to do. Let me repeat again. We are having the short side over the long side is equal to the short side over the long side. Can you see that? So what do we have now? We have BC. We have what? We have AC divided by AD, which is equal to BC divided by ED. Okay, now after having all that, we can just say AC wethu ngubani. Our AC is equal to what we have. Our AC is equal to, we have 3 plus 9, which is equal to what we have. 3 plus 9 is equal to 12. Then divided by, which means the reason here is what? Is prop theorem. Prop theorem. So we have 12 there. Then on that note, we are having 12 over AD. Our AD is equal to, now AC is 3. We have 3. Then AD is equal to 12. Sorry. Then is equal to, then BC is what we are looking for. BC is what we are looking for. Then ED is 9, because ED is this whole thing, 6 plus 3, which is equal to 9. So on that note, we are going to be having what? We are going to be having BC, which is equal to 27 over 12. Then if we press our calculator to simplify that, 27 over 12 is equal to 9 over 4, which is the same as 2,25, which is 9 over 4, which is 9 over 4. So this is the length of BC using this kind of situation. Then moving forward, otherwise we are just done. You can just write units here. Yeah, many informations. This is what we have. And moving to the next question. The next question says we are to find out what? We are to find out the area of triangle ABC. The area of triangle ABC divided by area of GFD. This is GFD. Now, what are we having? Which means BC, we found BC to be equal to 9 over 4. Good. Now, what do we need? We need to calculate what? We need to calculate the the ratio of these areas. Yeah, let me just take this away so that we have enough space to write what that is. So we have that. Now, the area, let me just write the area of triangle ABC divided by the area of triangle GFD. What is the area of ABC? We don't have any angle there. That's going to be a problem, but we're going to solve the problem. So what do we have? We have this side and this side. We have this side AC and side BC, that we are going to use this angle as an included angle for the area. Now we are having the area of ABC is half base. We can say base is AC times height. We can say height is BC, then times sine of an included angle. Then included angle is this one, which is angle ACB, So we are having that thing. Then divided by half. The area of GFD. Remember, we have this side, and we can use this included angle, which is angle D, which means we can say the base can be FD or GD, then times the height can be GD if your base is FD, then therefore times sine of D, which is the included angle, so times sine D. So if we can move forward, we're gonna substitute in the place of I can just say a half and a half, they cancel each other. Now AC is 3 units, then times BC is 9/4. Yes, then moving forward, we are having times sine angle ACD. But angle ACD njena uyalingana no angle D, remember, because these lines are parallel to each other, then therefore the corresponding angles are equal to each other. So I can just write angle D here because they are equal to each other. Okay, all right. Now what are we having? We are having divided by, then we have FD. FD is 3, then times GD is 4, then times sine angle D. So wow, so these angles are going, these things are going to cancel each other because they are the same. Then you'll be left with only the numerical values, and also these 3 cancel that one, and now we will be left with only 9/4 divided by 4, which is the same as 9/4 times 1/4, which is the same as 9/16. Okay, so this is what we have this is the ratio of these triangles. So 5 marks, you got it all. Yes. Now this is the end of that question. Then also this is the end of the question paper, ladies and gentlemen. This is the end of the question paper, and here is the message that I really plead you to respond into my channel. If I deliver what you want to hear, and it is very helpful to you, please react positively to my channel by subscribing, and also in the comment section you can ask anything. You can also suggest something. It's gonna be open just for everyone who are the members of my channel, and thank you guys for that. And I believe that it was fruitful, and you heard what you really want to see. Enjoy the rest of it. I will appreciate to see you watching, and thank you guys. Thank you very, very much. I really appreciate to have you, and I love you, everybody.